Hello everyone, welcome back to my channel Study With Me. Today I'm going to explain about Chemistry Standard Level Paper 2, May 2021, Time Zone 2. If you find this video is helpful, please don't forget to subscribe and let the other friend knows about my channel to support me. And let's get started. Limestone can be converted into a variety of useful commercial products through the lime cycle. Limestone contains high percentage of calcium carbonate. Calcium carbonate is heated to produce calcium oxide CaO. Above is the cycle. Calculate the volume of carbon dioxide produced at STP when 555 grams of calcium carbonate decompose. So because the mass of calcium carbonate is known, we directly can think that we can find the mole of calcium carbonate and divided by MR, which is 555 divided by molar mass of CaCO3, which is 100.09. You will get 5.55 mole. The question is asking volume of carbon dioxide. To find the volume of carbon dioxide, you need mole times Vm. So to find mole of carbon dioxide, we can see on the equation here, the mole of CaCO3, the coefficient of CaCO3 is the same with CO2 because 1 and 1. Therefore, the number of mole of CO2 is the same with mole of CaCO3, which is 5.55. Vm is constant, 22.7, and you will get 126 decimeter cube volume of CO2. Thermodynamic data for the decomposition of calcium carbonate is given. So calculate the enthalpy change of reaction. CaO and CO2 are the product. This one are the reactant. To calculate the enthalpy is the enthalpy of product minus reactant. So that would be negative 635 plus negative 393.5, which is CO2, and minus reactant, you will get plus 179 kilojoule per mole. The potential energy profile for a reaction is shown. Sketch a dot line label catalyze. Okay, so this one increase in enthalpy is an endothermic. So when you add catalyst, the activation energy will be lower. So we just need to make the curve a bit lower. So this would be catalyze. Okay, so lower activation energy curve between same reactant and product levels. These are the reactant, this is the reactant, and then this is product. Outline why a catalyst has such as an effect, because it provides an alternative way by lowering the activation energy. The second step of the lime cycle produces calcium hydroxide. Write the equation of the reaction of CaOH, calcium hydroxide, with HCl. So calcium hydroxide aqueous plus hydrochloric acid aqueous will produce, if you don't know how, so make it to be ion, Ca2 plus, OH minus 2 belong to Ca, H plus, Cl minus. So Ca2 plus will combine with Cl, Ca2 plus, Cl minus, crisscross, it will be Ca, Cl2. Aqueous plus OH minus and H plus, obviously it's H2O. So you balance them. Determine the volume in decimeter cube of 0.015 molar calcium hydroxide needed to neutralize 35 centimeter cube of 0.025 molar. So 35 centimeter cube of HCl, and this is the concentration of HCl. So we can count mole of HCl, C times V. So C is 0.025 times 0.035. You will get 0.00088. Based on the equation here, CaOH coefficient is 1. Therefore, to find mole of CaOH, it will be half, because coefficient of HCl is 2 times 0.00088. You will get 0.00044 mole. So now we can calculate volume of NaOH. So N divided by C, 0.00044 divided by 0.015, which is 0.029 decimeter cube. Saturated calcium hydroxide solution is used to test for carbon dioxide. Calculate the pH of 2.33 times 10 to the power negative 2 mole per decimeter cube solution of calcium hydroxide as a strong base. So CaOH, be careful, it has 2 OH minus here. Therefore, the concentration of OH minus, it's 2 times 2.33 times 10 to the power negative 2, which is 4.66 times 10 to the power negative 2. Okay, unless if it's like an AOH, then you can directly use this concentration. So to find the concentration of H plus, this is the formula. So this, of course, 1 times 10 to the power negative 14 is a constant. So H plus is the question here. And then OH minus 4.66 times 10 to the power negative 2. Then you will get H plus is 2.15 times 10 to the power negative 13 mole per decimeter cube. So pH will be negative log 2.15 times 10 to the power negative 13, which is 12.668. Calcium hydroxide reacts with carbon dioxide to reform calcium carbonate. These are the reaction. CaOH 2 plus CO2 produce CaCO3 plus H2O. Determine the mass in gram of CaCO3 solid produced by reacting 2.41 decimeter cube of 2.33 times 10 to the power negative 2 of CaOH. Volume and concentration is known, so we can calculate a mole of CaOH. C times V, which is 2.33 times 10 to the power negative 2 times 2.41, 0.0562 mole. Okay, with 0.75 decimeter cube of CO2. So we can also find mole of CO2, V divided by Vm. It will be 0.75 divided by 22.7, which is 0.033. Okay, so mole of CaOH2 is 0.0562, and for CO2 0.033. This one is smaller compared to this one, so this will be the limiting reactant. Therefore, mole of CaCO3 will be 0.033, because the coefficient is the same. So we refer to the limiting reactant. Now we've got the mole of CaCO3. So we can calculate mass of CaCO3, which is times molar mass 3.30 gram. 2.85 gram of CaCO3 was collected in the experiment in E1. Calculate the percentage yield of CaCO3. So percentage yield would be actual yield divided by theoretical yield. So 2.85 gram divided by 3.30 gram times 100 is 86.4%. Outline how one calcium compound in the lime cycle can reduce a problem caused by acid deposition by adding CaOH2 to acid water. Because when calcium hydroxide is added to acidic bodies of water, it will neutralize the acidity. The properties of elements can be predicted from their position in the periodic table. Explain why Si has a smaller atomic radius than Al. Si with atomic number 14 or electron 14 and Al with proton number 13. If we see or we compare them, silicon nuclear charge is bigger or higher than aluminum, as it has more proton number, so it causes stronger attraction to pull the outer electron. As aluminum is in the same period, it has the same number of electron shell. Thus, it has the same amount of shielding. Explain the decrease in radius from Na to Na+. If it's Na+ with number of proton 11 and Na 11 as well, but number of electron now it's 10, so the electronic structure is 2 and 8, and this one 2, 8, 1. As you can see here, Na+ has one less shell, so it will cause less shielding in Na+. So valence electron attracted more strongly to nucleus. State the condensed electron configuration for Cr and Cr3+. Cr with the electron number 24, and for Cr3+, now it becomes 21 because lose 3 electron. So the electron configuration will be 1s1, 2s2, 2p6, 3s2, 3p6, 4s1, 3d5, or Ar 4s1, 3d5, and for Cr3+, 1s2, 2s2, 2p6, 3s2, 3d3. So Ar 3d3. Describe metallic bonding and how it contributes to electrical conductivity, electrostatic attraction, between cations and a sea of delocalized electron can move in the lattice and are capable of conducting charge. Deduce the Lewis electron dot structure and molecular geometry of sulfur dichloride SCl. Molecular geometry, it's bent or V shape. Suggest, giving reason, the relative volatilities of Cl2. Cl2 has, as you can see from here, has lone pair, so it's polar molecule, has dipole-dipole forces, and H2O has hydrogen bond between O and H. Therefore, suggest, giving reasons, the relative volatilities of SCl2 and H2O. H2O will be less volatile compared to SCl2, as H2O forms hydrogen bonding while SCl2 does not. SCl2 has only dipole forces, which is weaker than hydrogen bond. Thus, their bond are easier to break. So easier to break, easy to melt, and easy to evaporate. So it has relatively high to evaporate. So the volatilities is so it will be more volatile for SCl2 compared to water. Consider the following equilibrium reaction. 2SO2 plus O2 produce 2SO3. So here three molecule of gas, okay, 2 and then 1, and this one is 2. So reduce number of mole of gas. So state and explain how the equilibrium would be affected by increasing the volume. Pressure, it's inversely proportional of with volume. Therefore, if volume increase, pressure decreases, okay, as volume increases. And reaction shift to side with more moles of gas. So shift to the left if the pressure decreases. If pressure increase, it will shift to the less moles of gas. So reaction shifts left. Oxidation and reduction reactions can have a variety of commercial use. A student decided to build a Voltaic cell consisting of aluminum, a tin electrode, Sn, and solution of aluminum nitrate and tin nitrate. Electron flow is represented on the diagram. For Voltaic cell, electron flows from anode to cathode. Okay, so we know this one anode and this one cathode. And between aluminum and tin, aluminum is more reactive. Therefore, we'll experience oxidation. So here will be Al, this one will be AlNO3, and this one will be tin, and this will be SnNO3. NO3 2. This is a salt bridge, and this will be voltmeter. Okay, anode experience oxidation, so it will lose electron. Cathode experience reduction, it will gain electron. So write the equation for the expected overall chemical reaction. For anode, it's Al. So here Al will be, these three belong to Al. So Al3 plus, these two belong to Sn. So Sn2 plus. So for the anode, it will lose 3 electron. Okay, so Al solid, Al3 plus aqueous lose 3 electron, and for the cathode it will gain electron, so Sn2 plus aqueous plus 2 electron, so that would be Sn solid. And because number of electrons are not the same, so we can multiple 2 here, multiple 3 here, so the electron will be 6, here will be 6 as well. We can eliminate them. So 2 Al solid becomes 2 Al3 plus aqueous, and this one 3 Sn2 plus aqueous becomes 3 Sn solid. You just add them, so that would be 2 Al solid plus 3 Sn2 plus aqueous becomes 2 Al3 plus aqueous and 3 Sn solid. Organic chemistry can be used to synthesize a variety of product. So this is butene, adding water, HNOH and H2. So the structure will be, the double bond will be single bond, and attached to first is OH, another one will attach with H, and the second one, the double bond will break and both attach to H. Determine the change in enthalpy delta H for the combustion of butene using section 11. This is the average bond enthalpy. I will always ask you guys to draw the structure so it will be clear what kind of bond that is involved in the molecule. Okay, for this one and this one for CO, and this one for OH. Okay, so as you can see, we have 8 CH plus 2 C single bond C plus 1 C double bond C plus 6 double bond O, produce 8 because this is 2. So 2 times 4, 8 double bond C double bond O, plus this is 2 as well, 8 OH. So 8 times 414, 2 times 346, plus 614, plus 6, 498. So 804 plus 8, 463. So the total will be 7,606, 10,136. Delta H will be 7,606 minus 10,136, which is negative 2,530 joule. Write the equation and name the organic product when ethanol reacts with methanoic acid. When ethanol reacts with carboxylic acid or methanoic acid, it will produce esters and water. Okay, so let's draw the Lewis structure. Ethanol when it reacts with methanoic acid will produce this O will attach to the C, OH will be discarded and H will be discarded, produce water. So the formula will be HCO, and then this will be O, and then we copy this CH2 CH3. Okay, so the equation would be CH3 CH2OH plus HCOOH will produce HCOO CH2 CH3 plus H2O. So ester will have a name, alkyl alkanoate. So we have alkyl here, which is 2, so that would be ethyl, and it has only one C, methanoate. Oxidation of ethanol with potassium dichromate can form 2 different organic products. Determine the names of the organic products and the methods used to isolate them. So ethanol is primary alcohol. When we oxidize them, okay, it will produce ethanol, which is aldehyde. And you oxidize them again, will produce ethanoic acid, which is carboxylic acid. And to isolate them, we will use, for the ethanol, we do distillation, and for the ethanoic acid, we'll do distillation and reflux. Combustion analysis of an unknown organic compound indicated that it contained only carbon, hydrogen, and oxygen. Deduce 2 features of this molecule that can be obtained from the mass spectrum. As you can see here, the highest number is 58. It's always the highest number is the molar mass of the molecule itself. Okay, so 58, it's a molecular mass of the molecule, which is 58 gram per mole. And what about 43? 43, when the molecule lose methyl or CH3 fragment. Okay, 58 minus 43 is 15. 15, it's a CH3 or methyl fragment. This is 15 gram per mole. Identify the bond responsible for the absorption at A in the infrared spectrum. A here is around 1700 to 1750, so it's a carbonyl. Deduce the identity of the unknown compound using the previous information, the H-NMR spectrum, and section 27 of the data booklet. As you can see, here is a signal, one signal only. So it means it has only one hydrogen environment. It means the molecule itself is asymmetrical because it has only one H environment. So the compound is propanol. let's draw the compound. So it's symmetrical. It's only one H environment. This 3H and this 3H are having the same H environment. So it's propanone because it has a carbonyl group from the IR, from the previous question. So it has C double bond O, it's symmetrical, and the MR also 58, C3H6O. So it's propanone. That's all for the explanation for Chemistry Standard Level Paper 2, May 2021, Time Zone 2. If you find this video is helpful for your exam preparation and revision, please don't forget to subscribe and let your other friends know about my channel to support me. Thank you for watching, and bye.